Although this may look like a big mess to you, it really isn't. This brings all of the wiring for this particular floor to one location. And from here, it goes out wirelessly, so that there's no need to run cables through your walls. There's no problem with wireless technology. It's making great leaps and bounds. So all of this cable brings it to the floor, and then you distribute it to the floor all in one place. Plan to be around forever. You have to plan for the day that you need to modify or make some changes. Therefore, every single floor of this building has its own electrical panel system, so that if a modification was needed to be done, it simply has to be done from these panels forward. You don't have to go back and do the entire building. So for example, we could remodel 2,000 or 3,000 square feet, and it would only be a matter of touching one panel. Come on in, we'll show you our elevator. What makes this elevator look any different than any other? It's the amount of electricity it uses. Typically when you push the button and ask for that elevator to move, it gives about a 25 kW surge of electricity that's needed. If you figure that this entire building might only use 100 kW of electricity most of the time, that initial surge just for the elevator is 25% of that. So we put in a modified motor that only uses 5 kW of electricity. So instead of peaking up 25% of our load, it now only peaks up 5% of our load. This may look like a bunch of messy pipes to you, but at one point Omega Optical was Brattleboro, Vermont's largest consumer of water. The water would come in and they're needed to cool down these chambers. We've gone to a recycled system where basically it's a closed loop and we use the water over and over again, which has now made Omega Optical be one of the town's smallest users of water. We reduced our water consumption by 98% by putting in a recycled water system. The machines and the people here know no difference. The only thing is we're not wasting that much water a year. The open concept on the piping, again, may look messy to you, but as you have to remodel areas as technology changes, this makes it very easy to change our air handling system, our water movement systems. So not only should you be building for today when you do a project, but where are you going to be in 2 years, 5 years, and 20 years? This entire area was designed that you could easily remodel as technology changed. What you're looking at is our new Helios machine, which was made in Germany. This machine uses up about 200 square feet of working area. The remainder of the 9,800 square feet of this working area does a volume which was equal to half of this machine. So again, as technology is changing, this one particular machine can do double what all of the other machines combined in this area can do. So this is part of the way that you can save for the future. Rather than having to add on the building, come up with technologies that allow you to use your square footage more efficiently. Innovative things we did which cost essentially nothing is to get into recycling. We recycle our cans, our paper. We've been able to cut down our amount of waste that's going to the landfill by 85% by a simple recycling program and educating our employees. Education is an important part of it. You cannot just implement programs, you have to then teach your employees how to work with it. In the summertime, have you ever backed your car out of a parking place after having the air conditioning on and there's a big pool puddle of water? Or have you ever been going by a factory and you see the drip, drip, drip? Well, this is one of our cooling units. But what we do is we take that drip, drip, drip water and we capture it and we send it to a pump and it goes to a storage tank. That storage tank, along with the other clean water that we use, is then used in the toilets for flushing. So in other words, when you flush a toilet here at Omega Optical, that water's already been used once for some other process here in the building. At the heart of our energy efficient system is what we call our tri-generation. We have 2 diesel generators that click on. Typically the diesel generators make electricity. In our particular case, those diesel generators do make electricity. We then save the heat that's created off those engines. And in the wintertime, those heats go through these pipes and heat the building. In the summertime, the heat is taken and it makes its first visit to an absorption chiller, which converts the hot into cooling and that's how we cool the building during the summer. And then when all of it's done using its energy up, it basically the water gets recycled back in, and it's a closed loop system for heating and cooling the building. At the heart of our system are two Deutsch engines. One of them is a 175 kW engine, and the other is a 145 kW engine. During most periods of the day, only one engine is needed because we never peak above about the 145 kW. However, there can be times during the day, middle of the day, and especially in the hot part of the summer, in which you need more energy, and both could be operating. So it allows us to run them both together or individually, depending on the need of the day. What you're looking at is the heart of our distribution system. Right here is a locked panel which basically says that we're getting electricity at this moment from the grid, which is Central Vermont Public Service. We then can unlock this, come down and consciously decide to go on one of the two generators or both generators at the same time. The reason for the lock system is so that you consciously decide if you indeed want to go onto the grid or not to buy your electricity. It causes a person to stop a minute, think, and say, is it worth it at this moment, or should we stay on our own power? What you're looking at is our absorption chiller. Again, in the summertime, it takes the heat from the diesel generators and it converts it into the cooling that we use for air conditioning on the building. Another innovation that we have are variable frequency drives. What's that? Well, typically when you turn a motor on, it wants to run at 100% power all the time. It doesn't need to. There's times it's like your car where you only need to have the accelerator part way down. So what we put in on all major motors are variable frequency drives, so they sense how much power is really needed, and it'll turn it on to that extent. What are you looking at? You're looking at an interior luminous emitting diode light. About 40% of our building is lit with LED lights. Here's an example as you look at this room. How does the use of LED lights transform into electricity? If we look at this one room, which is a large meeting/break room here, this has 20 overhead lights. If it typically had the 100-watt lights that you put in here, you would have 2,000 watts of electricity that you're using. However, these are 5 watts. 5 watts times 20 is we're using 100 watts of electricity. So in other words, 100 watts of electricity versus 2,000 versus 2,000 watts of electricity is the alternative. A simple thing like countertops. This is made out of regular natural wood as opposed to laminate wood. Therefore you save all the glues that you would otherwise have in a type of laminate. It doesn't give off bad gases as time goes on. When designing your building, it's important to keep your air intakes away from your air discharges. These 3 particular units are air discharge, nowhere near the air intakes which are on the other side of the building. Now if you notice the windows there, we don't open the windows. That throws off the cycle of the building. So they're there for light only, but not to bring the bad outside air back into the building.